So page 13 in your packet, if you need another packet, I know it has been a while, hopefully you don't, but there are extras up here if they are needed. Just a quick refresher. We have been talking about different types of lines, what makes them parallel and perpendicular, right? And we had to refresh our memories what negative reciprocals were in order to figure out our perpendicular. We used our slope formula often to find slopes. We decided what was perpendicular and what was parallel. And if they were neither, we just said they were intersecting. So anytime we have a neither, a perpendicular, or an intersecting line, there is going to be a solution. So turn your whole body. Stay focused, my dear. There's going to be a solution, and that solution is the point where they meet. So a system of equations is a group of equations. So mostly what we're going to be dealing with is two equations, but systems of equations can be more than two equations. The solution to a system of equations is the point xy that makes all, or in this case, both of the equations true. All right, are you ready? So let's write the equation of this first line. So first of all, if we're putting this in slope-intercept form, we have to figure out our slope, right? And our y-intercept. This is something we've been doing for quite some time. Oh. It looks like this at the front. Lines and systems of equations. Awesome. All right. So we have to decide what the slope is of this line. Where are two nice points? Is it going through every corner? Kind of looks like it. So it's going down 1, so -1 over 1. What's -1 over 1? If our slope is -1 divided by 1, what's our slope? -1, right? So far we have y equals either -1x or just -x, because m is -1. And then what is our y-intercept? Where is this line hitting the y-axis here? 0. So that's it. You could say +0, you could just leave it like that, right? So b here is equal to 0. So +0 would just be still y equals -x, okay? Now to write the equation of our second line, here what is our slope? It's going up 1 over 1, right? So m is equal to 1. So far we have y equals x. And what is our y-intercept here? -2, so -2. Describe the location of the point -2, 2. Okay, so here's -2 and here's 2. So this is the point -2, 2. So this point is on what line? This point's on the first line. only, right? Now we're testing that point in both equations. And what that means is we're putting in what for x? Which one of these is the x value? Remember, they're always listed as x, y. So we're putting -2 is equal to x and 2 is equal to y into both of these equations. Are you ready? So what are we putting in for y? 2 is equal to the opposite of -2. Remember, we always want to put parentheses in place of our letters. I should have done that over there too. So this simplified is telling us that 2 equals, yeah, what's the opposite of -2? 2. Does 2 equal 2? Yes. Yes. So it makes this first equation true. So let's test it in our other equation, the second equation. So the y is still 2. I'm using this equation here. We bring down our equal sign. Our x is -2 minus 2. So if we bring down our 2, 2 is equal to -4. Does that work for this? No. So that is not true. That doesn't check out. So it makes sense that it only is true because it touches the first point, or touches the first line. It's only true, makes the first equation true if we plug that in, if we test the point. Okay, so we're going to be doing a lot of testing. It's kind of like when we were substituting values in for variables before, simplifying expressions. But we've just got to see if one side equals the other. Okay. So describe the location of the point -1, -3. So -1, -1, 2, 3. This is -1, -3. So this point is on what? The second line only, right? So knowing what we just found out, it should make which of these equations true? Number 2. The second one, right? So let's test it in the first. So remember, this is what x is, this is what y is. We're using these equations. So -3 is equal to the opposite of -1. So does -3 equal 1? No, -3 does not equal 1. So let's bring down our second equation here. Y is equal to -3. So -3 is equal to -1 minus, what's our equation? -2. So does -3 equal -3? Yes. And that's what we are expecting to happen. Obviously, you have to be writing this down and showing this work. It's something that's expected that you'll have to do and understand how to show and prove, right? So describe the location of the point 1, -1. So here's 1, down 1. So this is the point 1, -1. We're talking about this point here now. 1, -1. So this point is what? On both lines. And knowing what we know about these, it should make both of them true, right? So it should work for both of them. So y is -1 is equal to the opposite of 1. Does -1 equal -1? Absolutely. Remember, I put this in for x, which was right here, and I put this in for y, which was right here. In my other equation, the y equals x minus 2. So I'm putting in y is equal to 1 minus 2. So -1 is equal to, what's 1 minus 2? -1. And that's what we would expect to happen, right? Which point worked in both equations? Well, 1, -1. Why do you think it worked in both? Well, wasn't it on both lines? So one way we're going to be able to solve our systems of equations is by graphing to see where they intersect. Okay? Any questions about page 13? So far, so good? Some of you are still writing, so I'm giving you a minute. All right. 14. In a graph, the solution to a system of equations is 14. This is page 14, right? Is the point where the two lines intersect. All right, so write the equations for both lines on the graph in slope-intercept form. So remember, y equals mx plus b. We need to figure out the slope and the y-intercept. So looking at this first line, find two nice points where they go through the corners. I might pick this one and maybe this one. So it's going down what? -1 to the right, which is +2. So this slope is -1 over 2, right? Rise over run. Change in y over change in x. So far, we have y equals -1/2 x. And what is our y-intercept? 1, 2, 3. So b is equal to 3. So we're going to say plus 3. Our second equation, we're going to do the same thing. Pick 2 points where they're going through the corner. This time it looks like just the opposite. So we're going up 1. So this is +1 over 2. So this slope is equal to 1 over 2. So far we have y equals 1/2 x. And where here is our y-intercept? 1. B equals 1. So we're going to say +1. what are the coordinates of the solution to this system of equations? So in a graph, the solution to a system of equations is the point where the two lines intersect. What is the point where the two lines intersect? Good. So our x value was 2. We open our parentheses, we write a 2, we make a comma, and our y value was also 2. Then we have to test your solution in both equations. So our y and our x are the same in this case. So we have 2 is equal to 1/2. Remember to use parentheses to remind yourselves that when we have a number next to a letter, it denotes multiplication. So I'm just rewriting it with my x value in place of my x and my y value in place of my y. So I still have 2 on this side. What's 1/2 of 2? 1. Oh, what did I do? I forgot to include my negative sign. So I was like, this isn't working. So I have -1 plus 3, which is what? 2. 2 plus 2. 2 equals 2. This is true. So do be careful that you're writing down the right equation. I left off my negative sign, and then I noticed, wait, this is supposed to make it true, so what did I do wrong? I went back and double checked my equation. So then I'm rewriting it in the second equation. So still 2 is equal to 1/2 times 2 plus 1. So 2 is equal to 1 plus 1. 2 does indeed equal 2. This is what we would expect, right? 2 equals fish. Yeah. All right. Try number 3. You're right. It doesn't matter which one you call the first and which one you call the second. Remember, your slope is your change in y over your change in x. And b is the point 0b. Your y-intercept. If you're getting stuck, I'm going to play a little catch up. So we know it's going to be y equals. We're looking for our slope of this first line. So I'm going to pick 2 points where they're going through the corners of the graph. going down 1 over 1. So here our slope is negative 1 over 1, which is negative 1. So you could say negative 1x, or you could say negative x. And then we need our y-intercept. So it's going through the y-axis at 2. So b equals 2. So I'm going to write plus 2. Your second equation. Pick 2 points. I'll pick this one and this one. Careful here. This one's going up 2 over 1. So the second one, we've got 2 over 1, which is simply 2. And our y-intercept is going down here through negative 1. So you should have written y is equal to 2 is our m, x, and b is negative 1. It says now, what are the coordinates of the solution to this system of equations? So on a graph, that's where these two lines intersect. So we have one line here and one line here. Where do they run into each other? What did you guys say? See where they're intersecting? This is the point 1 is our x value, comma, our y value is also 1. So this is the point 1, 1. So that's what I'm going to put here. And now I'm putting this x value and this y value into these two equations. So I'm saying negative 1 is equal to negative, is that right? Something's not right. Oh no. What did I do? Oh, I don't know why I put a negative here. It's just 1, right? So this first equation, y, when y is 1, is equal to the opposite of x when x is 1 plus 2. So 1 equals 1. Is that true? Yes, it should make that equation true. Here, y is 1 is equal to 2 times x, and x is 1 minus 1. So 1 is equal to 2 minus 1. Well, 1 does equal 1 once again. So you do need to show your work testing the solutions to prove that that is your solution. All right? Any questions on 14? All right, we're cruising right along then. Well done. All right, what are some points that would make this equation true? So I would do this. If x was 0, what would y have to be? So 0 plus 5 is equal to what? 5. So y would have to be equal to 5. If x was 1, we would have 1 plus 5, which would make y equal to what? 6. Do you guys see this? So, write a couple more points. Maybe you're going to pick 5. What happens when x is 5? Yep. What happens when x is 7? What's 7 plus 5? 12. 12. All right. So, any of these are true. With that being said, try the second part. So, maybe just start with 0 again. Right? 2 times 0 plus 1 is equal to what? What does y equal when x is 0? should be our y-intercept, which is 1. What does y equal when x is 1? Not 2. 2 times 1 is 2 plus 1 is 3. So what does y equal when x is 5? So what is 2 times 5 plus the 1 makes 11. So pick any number for x and figure out another y value. You want 17 for x? That is ugly, but whatever. So 17 times 2, right? Plus 1. Yep, so y is 35. There you go. No, I'm done. Alright. They're giving us now an equation, and we're testing it to see if it makes it true. So remember, these are always listed as x, y. So we're putting in x for x and y for y. What are we putting in for y here? 2. So 2 is equal to 3 times what? What is x? 0. Be sure you're showing this work. Does 2 equal 0? No. So we're going to say no. And I'm going to kind of skip back and forth so that we aren't like running into each other. So what am I putting in for x now? 1. So 3 times 1 is equal to what is y? 3. Does 3 equal 3? Yes. I know it seems elementary, but do write it out. Do prove your work and show your work. So, because they're going to get more complicated, right? So here we're saying yes. This one we have to put in a 12 for y and a 4 for x. Does 12 equal 12? Yes. So we're going to say yes. And the next one, we have 13 for y is equal to 3 times 10. No. Does 13 equal 30? No. No, it does not. So we're going to say no. Do you see how we're testing these? All right, we just have one more to test. I'm going to practice the first one with you. Ready? -1 is y. We have a new equation, so don't go back to the old one. 4 times 0 minus 1. So this is -1. This is 0 minus 1. Does -1 equal -1? I'm pretty sure it does. So we're going to say yes. And then that's what you would do here. 3 is equal to 4 times 1 minus 1. Does 3 equal 4 minus 1? Yes, because 3 equals 3. All right, you try the last two. Plug those into this equation. Show your proof. And then you're deciding yes or no. And that is the perfect place to start. Stop, rather.